Beautiful, lovely afternoon. Thank you all very much for joining me on this for this webinar on urban stormwater catchment planning on demand. I'll do a few minutes on the housekeeping side of things before I actually start the presentation. Just to let you know, the presentation is being recorded, so you'll be sent a link of the entire video, so you can enjoy your lunch without trying to print screen everything. I'll also try to share the slides, which I'm sharing with you, so that would be perfect as well. And yeah, so what else? Let's get started with the next slide. So as you know, this is the third of the webinar series. We had one in August on the inland part, and last month we had it on the marine, and this month we are having it on the urban. I'll share with you the webinars which are coming up later in this month as well. The webinars which happened before, they have already been sent to those who attended, and those who can't, there is a YouTube playlist. And I'll send you this link later on, so you can actually see all the videos if you're interested in these particular domains. As you know, DHI works in these 3 different domains, and we would like to share all the new innovative stuff which we're doing with you all here in New Zealand. Right. So a little bit of background about myself. I'm Kalyan. I've been in DHI New Zealand for close to 18 months or more. I've been in this urban water sector for close to 10 years now. Been dealing exclusively with the water quality side of things, both on the coastal and the freshwater. So that's what my experience is. I love to focus, I love to do my research, and I love to work on areas wherever there is urban stormwater quality pollution, stormwater entering into the freshwaters and then polluting the receiving environments there, or entering into the coasts and estuaries and polluting the estuaries there. So I'm interested in all different aspects of stormwater pollution. And that's why I'm super excited to present to you an innovation which we did here in locally in New Zealand in collaboration with the University of Canterbury, keeping the customer in mind, keeping you all in mind, because I know that most of you deal with microurban and deal with customers who are trying to address their stormwater pollution problems. So we want to do something which is very interactive and which is very useful for you all, so that you can have much more meaningful discussions with your clients and spend less time trying to figure out which bells and whistles to change in your software. So that's the whole gist of this thing. So as I said before, everything is being recorded, so I hope you're enjoying your lunch on this lovely sunny day. Little bit of background about the mic products. We are there in pretty much every type of water environment you can think of. Right now, I'm going to focus the next 20-30 minutes on the integrated urban water modeling side in the city areas. So modeling and GIS and what kind of solutions we have for that, and how you can make best use of it. Now, if you have any questions, feel free to ask, but they will all be addressed at the end of this webinar. And if you need more clarification, you can just ping an email to me. I'll bring my email address again at the end of the webinar, and then if you need more information, you can always contact us, which you already have the information about. So whatever software we develop, we are not like keeping it for ourselves. We want to train others. We want others to use it, give us feedback so that we can make it better the next time. And we can customize the software to whatever license types you wish for, and we are very much into capacity building as well. So this particular innovation, which I'm going to share with you today in this webinar, it's all subscription based. So just like how you log into your Gmail or your company accounts, similar to that, just put in your user ID password and you can get a complete access to how things are changing. So we can talk about how we can work together on this particular innovation. Right. So interesting fact, I like to start my presentations with interesting facts. This is something which I saw last year in a presentation in Wellington, where this professor was trying to compare the population of New Zealand with now with how it was close to 100 years ago. And he said that, look, 100 years ago, there was an equal divide of urban and rural population, but now it's like 85% of the people live in urban areas. Actually, if you Google up and find the most urbanized countries in the world, you would find New Zealand sitting high up in the list, although you wouldn't think so. But most of us live in urban areas, so that's a huge thing. So what it means is that we have to gear up for meeting these urban demands, not just in water, but also in infrastructure and planning and all that kind of stuff. So, and we have so many things going on. There is so much pressure, demographic pressure on all the basic needs. So we wanted to make your life simple so that when you go out and talk to the clients or the end utilities, or you might yourself be the councils, and you want to make your life simpler as well, so that your decision making is faster and more scientific and more rigorous. So you can have your discussions with your clients, with your management, with your community groups, with your stakeholders in a much more meaningful way. So that's what we are here trying to do. And DHI has been in New Zealand for close to 15 years now. And that's what we have been doing for the past 15 years, not just supporting you with your queries on Mike software, but also helping you create local innovative solutions to address these growing population problems. Right. So in urban areas, especially, well, this is something everyone likes, having nice rain gardens and swales and bioinfiltration systems and stuff like that. And recently, during the Water NZ conference, Cheryl Barnes from MFE was mentioning how Hobsonville at Auckland is doing amazing things when it comes to having this water sensitive urban design in their community, and how it could be a model township for the rest of the country to follow. Now, it's all really great. I mean, Auckland, I'm guessing I don't have the right number at the top of my head, but maybe more than 100 of such things exist all over Auckland, maybe more. So they provide great benefits in terms of source reduction and on-site treatment. But once you have an established brownfield, it's very difficult to retrofit, and then you got to find which one is the council land, which property owner is willing to spare some of his land so that we can put these things. And all these different questions exist. And most of the time, it so happens that we try to build these WSCDs wherever the land is available, not really checking if it's really fitting for purpose when it comes to source reduction, when it comes to trapping sediments, and when it comes to removing or mitigating heavy metals and nutrients from the polluted sites. So that's a big question. How do we address that? So that's another big thing. And whenever we look at any state of the environment reports, which the councils, regional councils publish, I mean, the left, you see the Auckland Council one. This is just the central area, the Auckland city. And on the right, you see the Christchurch one. Even though we have so many water sensitive urban design elements all across our central areas, still you find the water quality, which is represented in these dots in different colors. I know, and the legend says red. This traffic light color is always like red means bad water quality and green means good water quality. So no matter what, we still have these problems of having bad water quality whenever councils go and measure the in-stream concentration. So why is it happening? So that was the starting point for this work, which we tried to do. And then we went to the councils and asked, well, why is it happening? You guys are putting in so many WSCD elements and still you're finding this in-stream concentrations. And then they come back saying that, look, urban hydrology cycle is very difficult for us to navigate through. You have pervious areas, you have impervious areas. We are hoping that the pervious areas will trap most of these contaminants, but what happens to the things coming up from impervious areas? How do we trap them? How do we make sure that they don't end up in the receiving environment? So those kind of questions exist. And they were like, we don't really know how much of these overland flows are able to trap the pollutants coming from the impervious areas before it enters into the stormwater network. And is there a way to find out where we should focus our efforts on, and what kind of mitigation we should focus our efforts on? So those were the kind of questions which we received when we were speaking to the councils regarding this particular issue. And literature has shown pretty much all over the world, it's not just New Zealand, when we come to impervious surfaces, which might be smooth asphalt or coarse, you can have pollutants ubiquitously. You'll find suspended solids. That's why the waterways become brown and murky. And you also have these heavy metals, zinc and copper. I know there are ANZAC guidelines and you have to follow them, but most of the time it doesn't happen. That's why the water quality, the traffic color shows red, consistently for those particular spots is in the urban areas. So question is, how do we deal with it? So it's not just about these heavy metals. You can find other kinds of like polyaromatic hydrocarbons and oils and even nutrients. And then if there is no flow, then you can have nice green algae growing. And then as you see in this left picture, so brown and murky waterways. But we all aspire to live in neighborhoods which have free flowing waters, which are clean, and really want to enjoy such things. So how do we address this? As most of you are MicUrban users or are planning to use MicUrban, I strongly recommend. You might be thinking, sure, we have this problem. Let's try to use MicUrban because MicUrban is a complete urban water modeling environment. So it not only does for stormwater, but also for drinking water, but also for wastewater, and you have the whole GIS integration. So that's really great. And that's when we said, look, we already have a tool, MicUrban, and it's really great to address these problems, but how do we make it more, to give you this fast pace, especially in this area, in this era of big data and decision making happening at a faster pace? How can we make it more simple and more interactive and intuitive so that you can have your baseline model built in your MicUrban, trying to address different questions, but when it comes to doing your scenario making, when it comes to trying to glean some decisions out from the different scenarios when you're talking with the clients, have a very quick approach of getting the results. So that's where the whole thing started, and that's when we said, okay, let's try to work with someone to get this thing done, and that's what we did. And I'll come to that. So we try to identify what kind of system we should develop. And when we spoke to the councils, they said most of the time we are looking for a system which can help us identify the hotspot areas where this pollution is. And once we know where it is, we want to have scenarios which can help us develop different options, targeted options to mitigate the impacts at source rather than having a end of the pipe treatment options, and what kind of benefits we can get. So they want something which is very interactive and intuitive and can give results on demand, and so that they can make their decisions quickly, so that they don't have to wait for the models to run for another 7 days and 10 days to get back results and stuff like that. So that's what we try to address. So then we went back and said, okay, we tried to partner up with the university, and then with the university we identified that there are some things which are in use right now. So, but most of these, when it comes to stormwater quality, they are predicting or estimating the loads at an annual basis. Now, it has some benefits to give you an aggregated annual load, so that you can get an idea of how much toxicity could you expect on an annual basis. But annual basis is not going to solve your problems when you're trying to identify the hotspots, because you only know what's happening at the in-stream level, but what's happening at the catchment level, it's very difficult to figure out. And that's not the only limitation. You can see this slide. Someone who's a professor in communications will say, "Oh, too many words on the slide." That's a big limitation. So that's what I wanted to showcase through this slide as well, that these annual load models, they have a huge limitation as well, that not just identifying the hotspots, you can't get to know what the results are from individual events. So you wouldn't know whether you should be focusing on the loads, tracking them from the individual or smaller events. And then you wouldn't be able to figure out from which surface it is coming at and to which part of the stormwater network it is going, at the discharge point level. So there are lots of such problems which you have to overcome before you can make sense of the annual load model and the estimates which are coming from there, especially in the urban areas. So to address this, we worked with the University of Canterbury, and we came up with an online spatial decision support system which targetedly addresses those limitations which I just mentioned before, so that you can get your solutions very quickly and very intuitively at a spatial temporal level, which is much refined than what you have ever worked with before. So with University of Canterbury, what we did was they have been doing research in this area for more than 5 years, 10 years. developing new frameworks and new methodologies and the whole buildup and wash off of the pollutants. And they found out that, especially from impervious areas, the major factors which drive this pollutant load buildup and wash off are intensity and the dry days and the material type and the event duration. So keeping that in mind, they came up with a very interesting framework. They call it Medusa, a Greek terminology. It stands for Modeled Estimates of Discharges for Urban Stormwater Assessment, where just an example where you have a few of the impervious surfaces, few of the contaminants, and then you bring all of them together in this cauldron, and then you get your things out. But it's not a black box kind of thing. You have your buildup and wash off taking place. They have tested it, field tested it. A lot of research has gone into it, and have published quite a few papers into this. I think my next slide should be showing those multiple references which they have published on this Medusa framework. Now this Medusa framework has become the core engine for this online spatial system which we have developed. And what we have done is we have done a thing which is very customer centric and which can assist you at multiple levels. First of all, it is applicable for any surface type and for any rainfall characteristics. Now, this is very important, especially when you're trying to localize. Some of you might be working in Auckland, some of you might be working in Christchurch or Dunedin or Wellington, and you have different weather patterns, you have different surface types. So we have made the system modular in such a way that you can just feed in the different surface types you have in your catchment and load the different rainfall characteristics available in the public domain, and you quantitate how much loads are being generated on a per event basis. And it's not just about the loads. Thanks to MyCarbon, which you might have already run, it's possible to even determine how much flow is going through the stormwater network during those events, and eventually determine the concentrations and see how far away from the recommended guidelines you are from these recommended guidelines. We have made it very less input data intensive so that you don't have to spend a lot of time trying to figure out how to change the different input parameters. You just feed in your shape files, you just feed in your local metadata, and then there you go. If you already have a MyCarbon model, it has a seamless integration with it so that you can combine the pollutant at source model coming from or generated from the Medusa framework with the flow routing models so that you can get your concentrations at your desired discharge point in the stormwater network. So we developed a small pilot. We developed the system for a small pilot catchment in South Island, and I'm tremendously grateful to the champions of the system. They're really, really looking forward to implementing it on a day-to-day basis to see, and they see huge potential for their system. They see it as a system not just in their decision making, but also for communication with their stakeholders, with their residents, and generally very useful to see how much of the urban pollution they can address through this particular system. So I have 10 minutes left before I want to start this webinar open this webinar for Q&A. So I want to show a small screenshot, a small set of screenshots which I have gotten from the system. And if you're interested for a demo of the system, please definitely email me. We can have a one-on-one or with your team, and then I can show you how the whole system was, and you can have a play around with the system as well. So this is for a catchment in Christchurch. So this is a landing page. So you just put in your user ID, password to a URL, which we're going to share with you, and then just land on that, and then you'll get your catchment of interest. If your user ID is already logged into the system, we already know which catchment you are focusing upon, so we directly zoom into that catchment. And this looks like any typical urban catchment anyway. You have a lot of residential areas, you have a lot of car parks, there is some commercial warehouses around. So as you can see from this screen, there is a lot of impervious area in this urban catchment, and that's what we are trying to target as well, that how much of the pollution is coming from the impervious areas and where are the major hotspots which exist. So the intuition, what you call the intuition in the system is just, we call it on demand, because we felt that when you're trying to use Netflix or Spotify, you don't need any training. So we thought, why do we need training when we are trying to the system. So it should be as simple as that. So if you can watch movies on demand or listen to music on demand, so you should be able to even do this planning on demand. So that was the whole point why we call this contaminant loading or planning tool on demand. So moving to the next slide. So you can see it in different views, a road view or a satellite view. It's all integrated with a Google base layer. And once you try to query what is there in the catchment, I mean, that's the first step you want to do. What are the pervious and impervious surfaces which are already in the catchment, and what do I know about them? So that's the first thing you want to know. So you just identify or select the catchment outline, identify all the surfaces, switch them on, and then click on any surface. And then just like here on this right top corner, you can see that it gives you immediately an attribute information about what exactly you're trying to query. You're trying to query a roof surface, which is made up of galvanized moderate material. And this is the address for the property. And this is the surface area for the property. So all this can be obtained from the shape files which you provide us. And that's what has happened. So it's a very quick system. Once you have it, you're interested in how much pollution is being generated from each of the surfaces and where the hotspots are. And that's what happens. Since you already have your microurban model ready, and once you have the baseline model ready, so it's easy to run the Medusa on top of it, and then you're just visualizing the results down here. So that's the easy part here. I'll show you what happens next. That's much cooler than what you're seeing right now. So what you see on this particular web page or screenshot is an area of the catchment where you have different colors. So red color indicating high pollution coming out, green color indicating low pollution coming out from that particular surface and entering into the different discharge points in the catchment. So immediately you can get a eagle's eye view saying that, oh, this is the area which I should be focusing on, or maybe it's this area I should be focusing on. So if you are one of those stormwater network planners and you're trying to put in your WSUD, so there's no point putting a WSUD somewhere in this area where there are lots of green elements. I mean, it's not going to help much because all the pollution is entering like this and entering or coming out from here before it enters into the river. So it gives you that quick view. And for example, we have a few pollutants like suspended solids and zinc and copper. You can query the results not just on an annual basis, but also on a per event basis. We have identified specific events in a year which cause the wash off of the pollutant buildup, which is happening based on the number of dry days you have. And then based on that, we can say how much amount of wash off is happening and how much amount of what's the potential in terms of pollution load which each surface is generating. So that's what we try to do in this particular case. And we recognize that not every year has the same rainfall. Sometimes you can have an average rainfall. Sometimes you can have a dry year. Sometimes you can have a much wet year. So we have accounted for these different situations to see how the values change and how your hotspots change depending upon the year of interest. The cool part comes in when it comes to creating your own scenarios, where you can come and say, look, I am interested to change the material of my roofs, or I'm interested to build something along the car parks, especially the residential car parks, where I think my solution, be it be a stormwater treatment device or be it a green infrastructure like a vegetative swale, it can reduce 50% of solids or 50% of zinc. So you can play around with it, or you can say, I want to enter the pipe solution where I want to put in an LID down there at this particular subcatchment number 3. And the LID comes with these characteristics so that it can reduce 20% suspended solids and 60% copper and 50% zinc. So how does it relate to? So you can play around with it, and within a minute, you can get the results. And you can even click on this eye icon, which you see on the screen, and get recommendations of what kind of LID you should be putting in this catchment. And immediately you get a result saying that this is how it is. Let me bring the screen down. I hope I can. This thing. So as you can see, you immediately get a result. And when you query on one of the discharge points, what you will see is you will see a bar chart comparing your baseline with your new scenario results, and then telling you how much of a reduction you have achieved by putting in the new scenario. And you can see how the result is varying at an annual average basis for different rainfall patterns, at different discharge points, different surfaces, and for different events. So the interesting thing is the resolution can't get finer than this because you're identifying your pollution load coming from each and every rainfall event. And the spatial resolution can't get finer because you are identifying load generated from each and every surface, every property, every car park, every road, in your catchment. So you can't go much further. I mean, if you really want to go, it will take more computational power to go into every pixel in your catchment to find out how much load is being generated per every square meter kind of stuff, which you can generate. Just, you have your total pollutant load value, you have your total area value. So it's easy to find out how much load is being generated on a per area, per event basis, per unit area, per event basis. So in summary, this innovation, which we're offering as a subscription service, is built for local conditions. So it's great to be applied anywhere across New Zealand. It's very holistic and modular. It's very easy to build upon. Like the way we try to develop from the beginning is we are developing an iOS system, and then whatever apps you want to add, we just build on top of it. So you don't need to, every time when you do a new project, you don't need to develop the iOS. You just need to build the different apps. And the interesting thing is you can subscribe to as many apps as you want, and you can get benefit from these different apps. So as I said, it's event-based and it's surface-specific. So it's very unique in that sense. So you can get both spatial and temporal resolution at such fine level. And since it's subscription-based, there is no upfront cost, which you have to have a heated discussion with your manager to go and buy about it. You just subscribe, use it as long as you want it for your project. And as I said, minimal training. That's the whole purpose of it. It's an on-demand kind of thing. So you can just play around with it. Within a couple of minutes, you'll get a complete hang of how the whole system works, and you can use it for your group discussions internally or with your clients, or as public, or with your public communication, public stakeholders and stuff like that. So that's the gist of the whole thing. And this is basically, I think this completes the set of slides which I had for this webinar. So thank you very much for your patience. I hope you all stayed, and I hope you're enjoying your lunch while you're attending this seminar. So this is my contact details. So if you have questions and you want to have a demo of the system, you want to just have a go at the system and see how it fits your needs, definitely do email me, and I'll share the link with you so that you can have a better idea of what I'm talking about. So at this juncture, I also want to take this opportunity to share that there's another webinar coming up later this month. Emails will be sent to you. Any of you or your colleagues who are into ports and terminal, working on ports and terminals or coastal areas, they would benefit a lot from this. So I'll keep this slide on, but if there are any questions now, I'll see that. So please do share your questions, and hope to answer them. Thank you very much for your patience. Hello, James. Thanks for your question. What's the subscription cost? It depends on the catchment you have. So if you already have a catchment which has been modeled for its flow, so the cost comes down quite a bit. And it depends on how big the catchment is, what is the impervious coverage in the catchment. So we have kept it very focused depending upon the size and the area and what is already available, so that you don't have to reinvent the wheel, so that you can quickly have this on board and you can use this to talk to your clients, or use this for yourself if you're the end client. Just drop me an email. We can discuss more on the subscription cost based on what you already have. I hope that answers your question. Yep. Do I have more? Oh, sure. Great. Thanks, Stuart. Thanks for joining. Kristen has a question. Do we need to have a microurban model already built? It would be great if you already have the model built. Then it's very quick to extract the relevant flow information from the model, so that you can integrate it into the system and get your desired results. If not, you can work with us or work with the partners to develop the model for that particular catchment of interest. Shan has this question. Could you give an idea of what type of pollutants are considered and what surface types are predefined or user input? Right. So in terms of pollutants, for the pilot catchment, we have tried out suspended solids, copper and zinc, both in the total form and the dissolved form. We are integrating other pollutants like nutrients. So they are being tested right now before they are put on the live system. So let us know if you have any other pollutants of interest so that we can see the pollutant build up and wash off, test and validate how things work, and then we can integrate it into the system. Regarding surface types predefined, we have right now impervious surfaces, all type of impervious surfaces and pervious surfaces. So if you are interested in a specific surface, do let us know which you think is quite unique to your catchment. Then we can try to integrate it into the system as well. I hope that answers you. I hope that answers your question. Any other question? We have time for a few more if you're interested. Let us know. Just drop me an email. Yes, James has another question. Do we need to provide surface type as a shapefile? Yes. Just provide your catchment details as a shapefile. That's how the input module is built. So just type it in. Just give us the shapefile, or you can use the system yourself. And yeah, the shapefile is interpreted by the software. Yes. For one catchment live, yes. We are working on other catchments right now as we speak. So yes, thanks, Kristen. Let us know if you have a catchment in mind and if it has a different local characteristics and different types of surfaces, different pollution questions which you want to address. I'll be more than happy to touch base with you and learn more. Our surface types. So James has another question. Are surface types linked via the Mike Urban network? At this juncture, we try to make the system a bit model agnostic so that we don't face these problems of integration when we are working with clients who may not necessarily be using a micurban model. But definitely that integration is being worked upon. So that would make life much more easier. But if you have your models in a different network, we can talk about it. But right now, the linkage doesn't exist. So we take the shapefile separately into the system, and the micurban works in a separate parallel layer. So that integration, we haven't made it as a definite bit yet. So that might simplify your life if you're not using a micurban network. Do let us know if you have any concerns about that. Thanks for your question. So any other, those are beautiful questions. Kristen and James seems to be very active. Anyone else? Thanks, James, but this is very helpful. Yes, if you have any questions, further questions, after seeing the video, maybe you share the video with your fellow teammates. And if there are more questions, please don't hesitate to send us an email. You have all the information with us. If not, maybe I'll take this opportunity to thank you all once again and close this webinar.